Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome you all the students of class 11 for our chemistry lecture. As we have started chapter number 9, that is elements of group 13, 14 and 15. This is our last lecture and part 9 for the same. In our previous lecture, we have studied some of the molecular structure of some important compound of the group 13, 14 and 15 from the modern periodic table. Today we are going to continue the same topic with some of the different compound. So here is the compound silicon dioxide. Silicon whose symbol is Si. Dioxide means two oxygen, so silicon dioxide, its formula is SiO2. Silicon dioxide, it is commonly known as silica. Fine, we have listening the word silica, quartz, cristobalite and tridymite. These are the different crystalline forms of silica. It means the silica, it exists in different crystalline forms. In the form of quartz which we are using, we are having watch in our house. You see in that it has been written quartz. Okay, so cristobalite and tridymite, these are the different crystalline forms of silica, and they are interconvertible at a suitable temperature. Interconvertible means one form of it can be converted into another form at a suitable temperature. Silicon dioxide, that is a silica, it is a covalent three-dimensional network solid. The compound, that is your silicon dioxide, it is formed by covalent bond and it having three-dimensional network and it is in solid in state, in which each silicon is covalently bonded to tetrahedral manners to 4 oxygen atoms. It means one molecule, one atom of silicon, it is bonded to 4 atoms of oxygen. You keep silicon in the middle, then 4 atoms of oxygen at 4 different places, and these silicon and oxygen, they are bonded by covalent bond. The crystal contain 8 member rings. Totally we are having in a crystal, one crystal of silicon dioxide, it having 8 members ring, having alternate silicon and oxygen. It means alternate silicon, one silicon will be there, then oxygen, then silicon will be there, then oxygen. In this form, the molecule will exist. Here is the structure of silicon dioxide. Here you see silicon, then oxygen, then silicon, then oxygen, then silicon, then oxygen. It means it is alternately bonded to each other, and one molecule, let's see, take one atom of silicon. One atom of silicon is bonded to 4 atoms of oxygen. So this is the structure of silicon dioxide, that is your silica. And silicon is bonded to atom by covalent bond. Okay, and it is alternate silicon and oxygen, they are placed alternately, and one atom of silicon is bonded to 4 atom of what? 4 atom of oxygen. So this is the structure of silicon dioxide, that is your silica. Let's move further towards the next compound, that is your nitric acid. You're familiar with the word nitric acid, and it having the formula HNO3. Here nitric acid is a strong oxidizing mineral acid. It is a strong acid and it is used in the process of oxidation. Okay, that is an oxidizing mineral. So it is an oxidizing mineral acid. The central nitrogen atom is sp2 hybridized. We are having one atom of hydrogen, one atom of nitrogen. So here student, we are in the structure of HNO3, that is the nitric acid. We are having one atom of hydrogen, one atom of nitrogen and 3 atoms of oxygen. The center, in the middle, nitrogen is present This nitrogen atom is sp2 hybridized. Here HNO3, it exhibits resonance phenomena. Resonance means this is the here in the figure. It is the structure of resonance hybrid of nitric acid has been given. Yes, you see in the first figure. So here student, nitrogen is present at the center and it is sp2 hybridized. Then three atoms of oxygen, they are linked to nitrogen. You see here three oxygen, oxygen is present over here, another is here, and then okay, and the one remaining hydrogen, it is linked to oxygen. Fine. So this is the resonating structure of HNO3, that is your nitric acid. It can be, you see in the structure there is a difference in the first structure and the second structure, only the placing of bond. Here in the first structure you see the upper oxygen is having double bond, while in the second case the lower oxygen is having the double bond. Okay, and you see an arrow, when an equal arrow is there, it means both are same. Okay, so this is the resonating structure of HNO3. Here is the structure has been given below. The bond angle 96 pm, the bond angle between hydrogen and oxygen, it is 96 pm. The bond angle between oxygen and nitrogen, it is 140.6 pm, and nitrogen will carry positive charge. This oxygen, they will carry delta negative charge. Fine. In the first resonating structure, the below oxygen carry negative charge. In the second resonating structure, above structure, oxygen carry negative charge. Okay, so this is the nitric acid, which is a strong oxidizing mineral acid, in which nitrogen atom is sp2 hybridized and it exhibits resonance phenomena. Let's move further towards the last compound, that is the orthophosphoric acid, which is also known as phosphoric acid, whose formula is H3PO4. Okay, what is the formula for orthophosphoric acid? It is H3PO4. In the structure of orthophosphoric acid, we are having 3 atoms of hydrogen, 1 atom of phosphorus, 4 atoms of oxygen. Here student, phosphorus forms number of oxy acid. It forms number of oxy acid. This orthophosphoric acid is a strong, non-toxic. It is a strong, and as well as it is non-toxic, means it is not harmful mineral acid. Okay, so this phosphorus, it forms number of oxy acid and it is a strong, non-toxic mineral acid. It contains 3 ionizable acidic hydrogen. Here you see, we are having 3 hydrogen in the structure, 3 hydrogen atom in the structure of orthophosphoric acid. These 3 hydrogen, they are ionizable acid hydrogen. Okay, and at the center, phosphorus atom is present. You see, at the center, phosphorus atom is present and it is tetrahedral. Tetra means 4. Okay, you see at the center, phosphorus is present, 1 oxygen above and 3 oxygen below. It means it forms 2 are in the plane, 1 is above the plane, 1 is below the plane. As your carbon is there, it forms tetrahedral structure. Okay, so 1, 2 will be in the plane, 1 will below the plane, another will above the plane. You will study further stereochemistry, then you can understand what is above the plane, what is below the plane, and so on. Okay, we will give a demo lecture for you, inshallah. Then what is tetrahedral structure, student? Phosphorus, it forms 4 bond with oxygen. Okay, 2 are in the plane, 1 is below the plane, 1 is above the plane. Here the central phosphorus atom, it is tetrahedral, it is linked to 4 atoms of oxygen, and in which 2 atom, 1 atom leaving behind, another 3 atom of oxygen is linked to 3 atom of hydrogen. So this is the structure of orthophosphoric acid. This phosphorus, so student, this phosphorus forms number of oxy acid and it is a strong, that is your orthophosphoric acid, it is a strong non-toxic mineral acid. It contains deionizable acid hydrogen, and the central phosphorus atom is tetraatom. You see the structure P, double bond O, then O, then O, then O, and this below O, all the three O, it is linked to the hydrogen. So this is the structure of orthophosphoric acid. So here student, we have completed that chapter. The next topic which has been present in your textbook, it has been deleted for the current year, and you're not supposed to study it. Whatever we have done, that much is enough, and we have completed each and everything. Go through it, study well student, take care, do your best. Allah Hafiz. Thank you student.